Hello, everyone. Good morning. Thank you for joining my session today. In this session, I'm happy to talk to you about the brand new features that we just introduced in our recent public preview of Azure Event Grid. And I'm George Guirguis, as mentioned, I'm a product manager on the Azure messaging team. To start, I'll just go through a little bit of an overview of Azure Event Grid. We'll talk about push delivery. Then I'll dive straight into the brand new features that we just added into Azure Event Grid. First, the pull delivery. Then I'll talk a little bit more about MQTT messaging. For each of them, we'll go through the features that we added, and we'll see cool live demos of each of them. And then finally, we'll end with the roadmap and what features we have ahead of us. So first, let me start with the overview here. By raise of hand, how many folks here are familiar with Azure Event Grid? All right, okay, a lot of people. So Azure Event Grid is a pub/sub messaging broker. If you're familiar with Azure Event Grid, you probably know it for its push delivery or its push-push communication style that has been supporting event-driven messaging for years. However, in our recent public preview just 2 weeks ago in Build, we announced that Event Grid is evolving to be this hyper-scalable, elastic broker that now supports more diverse messaging patterns and multiple protocols. So just like Event Grid has been publishing messages or pushing messages to your subscribers now can start pulling messages from Event Grid through the new pull delivery support to give you, of course, the flexibility of choosing the delivery method that works best for your solution. We also added full MQTT broker functionality within Event Grid to support MQTT v3.1.1 and MQTT v5, along, of course, with existing support of HTTP. With that, I'll just dive into one by one of these features, and I'll start here with push delivery. So as I mentioned, push delivery here has been supporting event-driven messaging. It pretty much enables you to trigger an event from an event source to Event Grid, and Event Grid, in turn, will push that message to however many subscribers that you configure. We support, I think, up to 500 subscriptions today. For the event sources that are supported today, you can trigger these events from over 20 Azure services. A service, for example, like Azure Storage, sending an event like blob created, or Azure Key Vault, for example, sending an event that, hey, your cert is about to expire. And then you can push that message to your subscribers that will be able to react on this data. You can also trigger these events from partner services like SAP or from your own custom application. As Event Grid pushes that message out to your subscribers, you're able to filter this data through our very powerful filtering capabilities. You're also able to control the delivery settings, like, for example, retries. And as far as the destinations that are available today, Event Grid supports a lot of the Azure services that you've been hearing about over the past 3 days. Service Bus, Event Hub, Azure Functions, Logic Apps, and many more. But what if your scenario here or your subscribers requires that your subscribers control how fast or when to consume the messages from Event Grid? That's when pull delivery comes in. So as I mentioned, we recently introduced pull delivery in Event Grid, and this support here will enable your subscribers to pull messages out of Event Grid to have full control of their message consumption. So for example, if you have here a scenario where you have messages flowing into Event Grid at a very high rate, and there are spikes in your message rate, you can now have your subscribers pace themselves in their message consumption and pull their messages in the pace that matches their capabilities. Pull delivery will also support incredibly higher throughput than we've seen before from Event Grid. So just in our public preview, we're supporting 20 megabytes per second for ingress and 40 megabytes per second for egress. And we're just getting started here to reach our throughput goals. By GA, we plan to get to 100 megabytes per second for ingress and double that for egress. So again, if your scenario requires that incredibly high scale, then this pull functionality in Event Grid is the feature for you. Next, I want to talk about private link support. So private links were designed to be used when the client initiates the communication with an Azure service, not the other way around. So far with push delivery in Event Grid, you weren't really able to leverage that feature because Event Grid would be the one initiating the communication and sending the message to your client or pushing it to your clients. Now with pull delivery, you can have your clients or subscribers initiate that communication and pull messages out of Event Grid from a private endpoint in your virtual network. And the communication here between Event Grid and your subscriber will go over Microsoft's backbone network. And this functionality should expect it to be released by the end of this month. And finally here, I wanted to mention the capability that we provide your subscribers to control event states. Specifically here, as your subscribers pull messages out of Event Grid, they're able to either acknowledge the message, pretty much telling Event Grid, hey, I successfully processed this event, you can now delete it from the topic. Or you can release it for it to be resent or redelivered later on after a period of time. You're pretty much telling Event Grid, I'm not ready for this message yet, just give me a little bit of time and send it again. Or you could completely reject it. If a message is like malformed or just an invalid message and you want to completely drop it, that's when you reject the message. With that, I want to show you a quick demo of this pull delivery that we just added in Event Grid. So let me get to, we'll start with the control plane configuration here in the Azure portal. I think I need to reshare. Oh. Let me duplicate. Awesome. Perfect. So again, let me start with the Azure portal here. All right. So we'll start with the configuration here to enable pull delivery through Event Grid. So first, I wanted to introduce here this resource. In Event Grid, we introduced a new resource here called the Event Grid namespace. Think of the Event Grid namespace here as just a container for the resources that will host the pull delivery functionality, also the MQTT messaging functionality, or the MQTT broker functionality. Over here in the overview, you'll see two host names. One for the MQTT host name that your MQTT clients will need to address when they're talking over MQTT, of course. And then the HTTP host name that you'll be able to leverage for the pull delivery functionality. Here for the configuration, I very simply just went to the topics under eventing here. And you'll see that I created a topic here that supports, of course, the standard cloud event schema that we also support in push delivery today. If I go into the topic, and under my subscriptions, I have created here also a subscription under that topic for pulling the messages. Under my subscription here, I also wanted to show you that you can go to the filtering tab. And over here, you have just exactly the capable and powerful filtering capabilities that you're used to from push delivery. Now you can also leverage it for pull delivery based on your event schema. I can add here a filter. But for the generic use case, I'm not going to add one for this demo. Now, that's simply the control plane configuration. With that, I'll just show you very quickly the data flow. So over here in Postman, I have modeled like a publisher application and a subscriber app. The publisher application here will send an event to Event Grid. You'll see here I'm using, of course, the cloud event schema, a very simple event with some custom attributes, and sending a very simple payload demo. You'll see here that I'm using the publish API, and I'm addressing the namespace endpoint and the topic. And once I send this event, now I get the response that this was delivered successfully to Event Grid. I'll go to my subscriber app and pull this message. So again, here I'm using the receive API, and I'm also addressing the namespace endpoint, the topic name, and the event subscription that I created. And once I send this request, I get a response of the event that I just sent from the other application. Over here, you'll be able to see also the lock token, which pretty much identifies this message, and I'll use that for acknowledging the message. So I'll copy this from here. And I'll go use the acknowledge API, and I'll change this value here. And you see here that it was successfully acknowledged. Pretty much here, Event Grid has just deleted that message from the topic because we consumed it successfully. And that simply is the control plane configuration, even seeing a data flow of the pull delivery. Let me go back to my slides. Sorry. All right. So now that we talked about pull delivery that we just added in Event Grid, we'll talk about the other exciting feature that we just added in Event Grid. First, before I keep going, by show of hands here, who's familiar with MQTT? All right, a couple folks. Interesting. Perfect. So before I get started about the functionality that we added, I'll just go through a very quick introduction of MQTT and pretty much why you should care about using MQTT. So first, I'll start with why MQTT. MQTT is the ideal or the standard protocol for IoT scenarios. And IoT scenarios here have been becoming very pervasive and became very crucial part of the digital transformation initiatives across different industries. The automotive industry, manufacturing, retail, energy, and that's just some of these industries. In manufacturing specifically, if you're using OPC UA, then MQTT is the communication protocol of choice that you'll need to use along with it. And of course, all of these IoT scenarios generate vast amount of data. A regular deployment of, or a typical deployment of IoT scenario here would include hundreds of thousands to millions of clients that generate easy tens of thousands of messages per second. And all of this data needs here to be integrated into the rest of the Azure platform or the services that you've been listening about for the past 3 days to form that end-to-end solution, leveraging this data for use cases like storage, analysis of the data, and visualization, and even event-driven solutions, among other many use cases. So what is the MQTT protocol, and why is it suitable for IT scenarios? The MQTT protocol is simply a pub/sub messaging protocol that was designed for constrained environments, which pretty much describes all IT scenarios. It operates on push communication and the pub/sub messaging model, which makes it very scalable, as opposed to a typical client-server model that you might be used to from other protocols. And again, that's to support the enormous scale of IT scenarios, as I mentioned earlier. It's also very efficient and lightweight on the wire. And that's very helpful here for IT scenarios, as you would, for example, think of a solar panel in the middle of nowhere or a windmill sending telemetry, and their network is incredibly expensive. Every byte on the wire matters. It also has a lot of features to ensure reliability over unreliable connections. So think of a connected car scenario. You have this car going through in and out of connectivity zones all the time. And you don't want every time you initiate a connection, your messages get lost and then your configuration is lost. So MQTT here offer a lot of solutions to ensure this efficiency with unreliable communication. And finally, it's suitable, has a lot of features for constrained devices. Again, think here of you have PLCs, very incapable PLCs in factories, or small, tiny sensors in smart spaces solutions. The implementation of MQTT makes it very simple on the device side or the client side and offloads a lot of that complexity to the broker. And that's simply the two components of MQTT scenarios. You just have a ton of MQTT clients and then an MQTT broker in the middle to orchestrate that communication between them. And that's exactly what we added in Azure Event Grid. In Azure Event Grid, we added full MQTT broker functionality that will simply enable your clients to talk over MQTT. Some of the main capabilities here is the support of MQTT v3.1.1 and v5 based on the MQTT specs. We also support custom topics and MQTT wildcards. These two capabilities here will enable you to be able to talk to our service through any open source standard MQTT client. You don't need to learn a new Microsoft-specific way to talk to our service. You don't need to change your implementation or even your topic structure. It also operates fully on the pub/sub messaging protocol, pub/sub messaging model, which opens up the gate for all sorts of messaging patterns: one-to-one, one-to-many, many-to-one, many-to-many. We offer a very flexible access control model without compromising on granular access control. And through our first-party integration with the rest of Azure services, you can route this MQTT data, again, to integrate it in a full end-to-end solution and process it further. We also offer this capability to route the MQTT messages also to custom endpoints. Just two of the highlights here from our MQTT support will be persistent sessions and quality of service. So persistent sessions, again, if you remember my car scenario, that's a feature that would be very helpful here. So as a car would go in and out of connection zones, if it establishes a single session over multiple connections, it can just have a specific configuration for its subscriptions, and Event Grid will store this configuration and unacknowledged messages. So once the car connects back again, it just continues the session as if nothing happened. And the quality of service here, of course, you assign it to published messages to control the reliability of the messages. So quality of service 0 will be just simple fire and forget. And quality of service 1 will be at least once delivery. And we support both. And finally here, we support the gold standard for authentication in IT scenarios, which of course is X509 certificates. First, I wanted to talk about this custom topics capability and the benefit of it. Custom topics in MQTT do provide you with more flexible and dynamic communication over MQTT, especially with the wildcard support that would help you manage your subscriptions. We support both wildcards that are defined in the MQTT specs, the plus wildcard and the hash wildcard. As you see in these examples, the plus wildcard will match a single interval in the middle of a topic. So for example, if I have a topic in the example here that's devices /plus /GPS, that will match devices /device1 /GPS or devices /device2 GPS, etc. The hash wildcard will match multiple levels or multiple segments at the end of a topic. So if I have a subscription or a topic filter here that's alert /hash, will match alerts area 1 failure X or alerts area 2 failure Y, and so on. Now let's take a look at some of the use cases for MQTT here. First, the more popular use case here is ingesting all the IT telemetry that's coming from your fleet of devices. And you can do that through the many-to-one messaging pattern that we support. So each of your devices here can connect to Event Grid and funnel all the data to Event Grid. The Event Grid will be able to push to your backend application or multiple. Of course, here you see in this pattern, the benefit for you is that the backend application doesn't need to maintain that enormous amount of connections with each of the devices. It just maintains one connection to the Event Grid, and it gets all the data that it needs. You also see here in this example the use of the plus wildcard in action. So each of your devices would typically talk on their own topic that includes their own name or their own identifier. And the backend application here just needs to subscribe to one of the variations of these topics with the wildcard. And Event Grid is able to do that match between these topics from all of the devices and the topic filter that the backend application subscribed to. And that's simply to help the backend application here manage its subscriptions. It doesn't need to subscribe to the million variations of the same topic. Through the request response pattern, you're able to send commands to and receive responses from your devices. And this pattern also enables device-to-device communication without having a backend application in the middle, which of course makes this communication more efficient. I think we lost this. It's back. Through the one-to-many messaging pattern, you can broadcast messages or alerts in this example. And of course, you see the benefit here. Your backend application just needs to send a single message to Event Grid. The Event Grid replicates for every interested client. And of course, it's a lot more efficient and a lot cheaper, right? Your backend application doesn't need to send a million messages to start. You see also here the use of the hash wildcard. Your devices just needs to subscribe to a topic filter like alert /hash. They don't even need to know the rest of the alerts that get configured on regular basis in the service. They just know it starts with alerts. So they subscribe to this topic filter, and then Event Grid is able to do that match. And finally here, you need, of course, to integrate all of these MQTT data. We offer that through our routing functionality that enables you to push MQTT messages to Azure services and custom webhooks. And of course, this will enable you to make the most out of your IT data and IT telemetry by leveraging this data for use cases like storage, analysis, visualizations, event-driven architectures or event-driven solutions, among other many use cases. So we saw in the previous demo here, we introduced the concept of an Event Grid namespace. How we achieve this functionality here is that your devices talk to the namespace, send all the messages, then you're able to configure that namespace to push all of these messages to a custom Event Grid topic. And once the data is in the topic, it can create as many subscriptions as you would like to the final endpoints. Here you see an example of a popular example here, sending a popular endpoint here, sending the data to Azure Event Hubs, and then you can have an Azure Stream Analytics job, just grab this data and push it to the rest of your data pipeline. And of course, we will be investing heavily into integrating with the Fabric, Microsoft Fabric that you've been hearing about, and the rest of the Azure services that you've been hearing about for the past 3 days. All right, so the access control model. For the access control model, we offer here RBAC, or role-based access control, while addressing the scale challenges of IT scenarios. Again, IT scenarios have an enormous scale, and you don't want to give access to client by client out of your million clients to topic by topic out of your tens of millions of topics, probably. So we solve that problem by grouping. We group your clients into a client group, and we have introduced the concept of a topic space that represent a whole lot of topics in one go. And then through permission bindings, you're able to grant access to a specific client group to be able to publish or subscribe to a specific topic space. The topic space configuration as well supports that granular access control that I was speaking about before, and we'll see in a minute in the demo, by the use of the variables that will enable each of the vehicles to talk on their own topic, and Event Grid will authorize only specific vehicles to talk on their own specific topics. So none of the vehicles will be able to publish messages on behalf of each other or listen to messages on behalf of each other. With that, we'll dive into the demo. Before getting into the demo, I just wanted to show you the use case here that we'll be demoing. In this example, I just have a couple of vehicles, 5, 6 vehicles that I have created that are sending their location data. And then you have a backend, a couple of mapping clients that just needs to listen to this data to keep track of where every vehicle is. I also want to visualize this location data in a Power BI dashboard. So I'm sending this data to Event Hubs, and I'll have an ASA job or Azure Stream Analytics job pull the data from Event Hubs and push it to my dashboard. With that, let me show you how we're going to achieve this. All right. So again, I'll start here with control plane configuration in the Azure portal. Again, from the namespace that will host the MQTT functionality as well. And again, in the overview here, you'll see the MQTT host name that we'll use in this scenario. So the first step here of my configuration, since my clients are using CA signed certificates, I went ahead and uploaded my CA certificate. This will be the root certificate that have signed all the leaf certificates of each of these clients. And then you upload it here to Event Grid, and Event Grid, as it gets each connection from each client, it will validate that the leaf certificate was signed by this root certificate and authenticate the client. Then I went ahead and created a resource for each of my clients. You'll see here that I created a resource for my vehicles, for each of the vehicles, and a couple of mapping clients as well. If you go look at one of my vehicles here, you'll see that I also have specified in the configuration the client authentication name. This is the name that the client will present to Event Grid as it's connecting to Event Grid to authenticate the client. And also we specified here where the Event Grid should look for a match in the leaf certificate. In my case here, it's the subject field of the client certificate. And finally here, I added a client attribute. The client attribute here is just a key value pair that just describes my client and will mainly be used here for grouping these clients, similar clients of the same attributes. We'll also see its use cases across the rest of the functionalities. If I go back, look at the mapping client, one of the mapping clients, you'll find very similar configuration over here. I just gave it a slightly different attribute. The type is equal to map instead of type equal vehicles. Now that I created my clients, it's time to group them. I created here two groups for my clients, the vehicles group. And we don't have static groups that you really will require you to take an action every time you add a client. You need to attach it to a group. No, to make this configuration a lot more scalable, we support dynamic groups. The group clients using these queries based on the client attributes. So here, pretty much this query saying any client with attribute type equal vehicle, just make it part of this client group. In the same way here, I created another client group for my mapping clients. All right. The next step here will be to configure the topics that these clients will communicate over. Here I created two topic spaces, one for each, one for the vehicles to communicate on published messages, and one for the mapping clients to subscribe to. Topic spaces here represent a whole lot of topics through a group of topic templates. These topic templates, think of them as just MQTT topic filters with wildcard support and added support for variables. We'll see here the use of variables in this topic template, vehicle/authentication name variable /GPS. When the clients start communicating with Event Grid, they will of course replace this variable with their actual authentication name. And Event Grid will look at the client authentication name and then look at the topic it's communicating out, and then will only enable, for example, vehicle 1 to communicate the topic that includes vehicle 1 as an authentication name, and vehicle 2 to talk on the topic that includes vehicle 2. And this is how we provide granular access control through this variable support. So you see how you can give an access to a whole client group to talk on this topic template. The client group can have millions of, or a million clients, but you're still able to control access for client by client, which topic will they be able to access. In the same way here, I created a topic space for my mapping clients. You'll see here that I replaced the variable with a plus wildcard. And that's, of course, because I want my mapping clients to just listen to all the topics, not just a specific one. And finally here, for the last piece of the puzzle, is permission bindings. So I created a permission binding to give access to the vehicles group to publish on the topic space that I created for them, and the mapping clients to be able to subscribe on the topic spaces that I created for them to subscribe. Now that we've seen this configuration, let's take a look at the control plane configuration, the data flow, I'm sorry. So here in MQTT-X, you'll see that I modeled all my clients here, my vehicles, and the mapping clients. After my mapping clients here got connected, and give them a second to connect. All right. So the first mapping client got connected, and the second one, I'll connect it as well. After they got connected, they subscribed to this topic filter. If you remember, this is exactly the one that we set for them in the control plane configuration. And this enabled them to receive all of these messages from all the vehicles that they've been sending. Each of the vehicles have been sending their location data on their own topic. You see here, vehicle 1 substituted the variable with its own authentication name, vehicle 1, and sending its location. Vehicle 2 did the same with its own authentication name. Let's see the last message here in action. So I'll connect vehicle 5 here. And again, talking in its own topic that includes its own authentication name, I'll send its own location. And you'll see here right away that both of my mapping clients received the message, the same message. And this is pretty much the data flow and the pub sub between MQTT clients. Now let's go take a look at the routing flow. So I'll go back here into my namespace. and I'll go into the routing configuration. As I mentioned, we accomplished this functionality by sending the data to our Event Grid topic that will be able to push it to multiple subscribers. So here I configured the topic that I'll be sending the data to. It's this topic. And I also added configured enrichments. Enrichments are just key value pairs that you'll be able to stamp on messages being routed outside of the Event Grid namespace. And here I added a simple enrichment, just a client, and I'm using the client authentication name variable. So the Event Grid here will stamp the authentication name of each of the clients on their own messages as they're being routed. All right, to look at the next step here in the routing flow, I'll go to my topic. You'll see that I created a subscription here on that topic that sends the messages to, we'll go into the subscription. We'll see that it sends the messages to this Event Hubs instance. And this Event Hubs instance, I want to process the events with Azure Stream Analytics, and I was able to use one of these no-code experiences to create the simple flow. The simple flow pretty much just takes the data out of the Event Hubs instance and pushes it to my Power BI dashboard. If I go to my Power BI dashboard here, you'll be able to see the entries that I've gotten from, let me try to expand this so you can see it. All right, so you'll see here the entries in the table from all the messages that have been sent by each of my vehicles. You'll see here the source includes the namespace name. That's common, of course, across all vehicles. The subject that will include the topic that each of the vehicles have sent the messages to. The client name, authentication name that I have enriched by Event Grid. And finally here, the data field includes the payload. If I refresh this, we should be able to see, the last message that I just sent a minute ago. And over here, of course, you'll be able to see the in the map that is synced with the table, the location of each of the vehicles. So you can use it to focus on the location of each of the vehicles. And of course, this is synced with the table. So you can use also the table to get exactly to where a specific vehicle is. And that's simply the data flow here for the PubSub, and we've also seen the routing flow and how we get messages from Event Grid all the way to a Power BI dashboard. With that, I want to share with you our roadmap and close with this. So as I mentioned earlier, just 2 weeks ago, we went public preview with a lot of these features that I've just talked about today. The pull delivery and the MQTT broker functionality and the routing of MQTT data. And as I mentioned also, by the end of this month, you should be able to see the private link support for with pull delivery. We're planning to go into GA towards the end of this year. And in GA here, we're planning to support JWT authentication for MQTT clients, and we'll do that through AAD to give your MQTT applications a more convenient way of authenticating, rather than the X509 certificates that's more typical authentication mechanism for devices. For pull delivery here, you'll also be able to pull messages coming out of your Azure services, just like you're able to pull messages from your custom applications today. We'll also get to the higher throughput that I mentioned earlier, 100 megabytes per second. We'll also support 31 days for message retention. And for push delivery here, we're planning to support blob storage as a destination. And beyond our GA, we have a long, long list of exciting features coming up. And this is just the highlights of the main categories. We're planning to add more and more MQTT features. Namely here, I want to highlight retain flag support, last will and testament, which will make us, of course, Spark Plug B compliant to support this plug and play over MQTT. We're also looking at a feature like shared subscriptions in MQTT v5. And again, we'll continue to add more diverse authentication mechanisms for MQTT clients to just give you the flexibility to use the authentication mechanism that suits your scenario. So we're looking to add username and password and custom auth. And for pull delivery here, we're also planning to support order delivery and event replay. With that, I just wanted to leave you with just a couple of links here. You can use these AKA links to reach our documentation. As you've seen from our demos, the configuration and getting started is just incredibly simple. So you can go to our documentation, follow one of our quick start guides, and just get started today. This blog also will include our announcement blog for the preview, and we'll have also a video demo of from what I've showed today. And if you have any questions, feedback, comments, please feel free to reach us at askgrid@mqtt@microsoft.com. Sorry, askgrid@microsoft.com or askmqtt@microsoft.com. Thank you for listening. Do we have time for questions or? Go ahead. Sorry. Yeah, go ahead.
Obviously, Event Grid was released a number of years ago. I remember a young and handsome Dan Rossanova standing on the stage and talking about the reactive programming mechanism of it.
Yeah.
One of the reasons for that, of course, was to get rid of the need to do hammer polling. Mm-hmm. Right?
Yep.
There's now pull support.
Yes.
In Event Grid, which sounds, and given the 3 states, which are awfully like autocomplete, peak lock complete, peak lock abandon, looks like that's a service bus. Looks like that's a message queue. So that's question number 1, or about the context of the question. Question number 2, MQTT support, which isn't in Event Grid, sorry, in Event Hub, but is now in Event Grid.
Yeah.
Event Hub is the thing that runs underneath IoT Hub, which supports MQTT.
Yep.
You can see where I'm going with this question,
yeah,
I guess.
Yeah.
And IoT Hub also has a provisioning service and a device registry. So the MQTT support in Event Grid looks very similar to IoT Hub.
Yep.
So what's the future
of
all of those services, I guess is the question. Understood.
Thank you for your question. So let me answer one by one here. First, about the pull delivery. So again, as I mentioned here, we're introducing another method here for consuming the messages that would best suit your scenarios. And of course, there's similarity between the same functionality in Service Bus here and what we're introducing in Event Grid, but you'd use them for separate use cases here. So if your use case here requires the hyperscale for your solution, then the pull functionality in Event Grid would be the functionality for you that you want to leverage. Especially if you want.
Very quick follow-up question from Matt there. Elder was talking yesterday about large-scale messaging scenarios.
Yeah.
So where's the line?
Yeah, so that's for the scale of the messages as well as the number of clients that you'll be able to connect on both sides. So Event Grid here, if you have a scenario where you have a ton of clients publishing messages to Event Grid and a ton of clients consuming these messages of Event Grid through pull functionality, so that will be, again, the feature that you want to leverage. Service Bus here will continue to leverage here, or will continue to include the advanced enterprise queuing features like transactions, GMS support, and that will continue to only exist in Service Bus. It will not be supported in both services. So here, again, you see based on your needs here, you might leverage one of the functionalities or one of the services or the other. Now for the next question here, you also were talking about the MQTT support. So IT Hub does support MQTT, but its MQTT support is incredibly limited today. And that's why we introduced this full MQTT broker support that runs on PubSub, support custom topics as opposed to the predefined topics that IT Hub supports.
So a follow-up question to that then. Why not bring that support into IT Hub, which already has a device registry and already has a provisioning service
Right.
to support those large-scale IoT solutions, and already supports in-chip burning of things like the X509 certificate to facilitate all of those tasks?
Yeah, understood. The reason here is that we're looking at this offering here, and Event Grid already has the powerful, performant, and scalable infrastructure that we're able to leverage for the real and full support of an MQTT broker. IT Hub here, you'll see that it's support of MQTT, supports mainly, it's sort of more of a client-server model built on top of MQTT. So again, to not be restrained by some of the limitations that might be in IT Hub for its implementation of MQTT and its underlying infrastructure, we chose here to include this functionality built on top of the infrastructure and the architecture of a solution that really sounds like the perfect home for this functionalities based on the capabilities of that broker. So the yeah, that's the next point. Yes. Yeah. So yeah, I'll follow up one by one for that one. So yes. Yes. So the strategy here pretty much is that if your solution requires MQTT messaging, our recommendation here is to use or leverage Event Grid or start with Event Grid for the IT messaging using MQTT. So that charter of MQTT messaging has moved to Event Grid. As far as you rightfully mentioned, the Azure IT Hub, actually as well as the rest of the IT services, include a lot of great features for device management, device updates, Defender on devices, etc. All of these features, as we continue to develop our roadmap, would be able to integrate with. So we'll have this end-to-end solution and our offering from our side by the IT services being able to offer this device management capabilities. And then for messaging, you'll be able to integrate it with Event Grid to have your end-to-end offering from our side. Well, thank you for your questions. And I think I'm a little over time, so I'll take I'll take the rest of the questions outside. But yeah. Thank you, folks.